That's why. All right, so our learning target for today is I can solve one-step linear equations in one variable. It's important for you guys to understand what it means by one variable. It means that you will only have one letter term. It'll be an X term. There won't be like an X and a Y. That's because in some situations, yes, you can have more than one variable term. It could be y equals mx plus b. That is what we call slope-intercept form, and that's something that you're going to be learning more about once you get into your algebra class. We might hit it a little bit next semester as well, as just an introductory. But when we say one variable, it means there's only one letter, one type of letter. So there might be multiple x's. So it might be 3x plus 7x is equal to 10. Then you'd be solving that. You would just be combining those x terms together. So you would only have one specific type of variable that you'd be focusing on. Now, you've been doing equations since you were in kindergarten. When they pose to you the question of you had, 7 apples, and then you went to the apple farm and bought more of them, and you now have 12 apples. How many apples did you buy? That's an equation. When you had to figure out, well, what did I have to do to that value to get to the next value, that's actually an equation that you're creating. So you also saw it in the format of, hey, guys, if I have this box and I'm going to add 2 to the box to equal 7, what do you think the box needs to be? What do we add 2 to equal 7? You have this format since you were in first grade. Now you're going to see it as, instead of a missing box or instead of a, oh, well, how many apples do you think you purchased? You're going to see it as a variable. So it's x plus 2 is equal to 7. So we're building up on that prior knowledge that you've had. We're just putting it into a new framework, giving it a new term. So it's an equation. You're finding an unknown value or a missing value. So in order to do that, we use what we call the inverse operations. Who can tell me what is another word that we use for the word inverse? What's another way to say inverse? Diana? Opposite. So when we say the term inverse, we are talking about opposites. We are discussing opposite operations. So addition and subtraction happen to be opposite operations. So if I want to undo an addition problem, I just need to subtract to undo that addition. And here's what I mean. If I have a value like 12 and I add 3 to that value, but then I go and I subtract 3 from that value, what am I left with? 12. We're left with 12. It's as if this plus 12, or sorry, this plus 3 and this minus 3 never even happened. They canceled each other out. Same thing when it comes to multiplication and division. With multiplication and division, they are inverse operations to each other. They are opposite operations. So if I take 12 and I multiply it by 3, but then I divide it by 3, what am I left with? 12. Because again, multiplying by 3, but then dividing by the exact same value, it's as if they never happened. So I'm just left with the value 12. So when we try to solve for an unknown, we do the opposite of the operation that we see. So it's really important to identify what do you see and what is its inverse. So that is the question you should always be asking yourself. Question number 1, what do you see? And then question number 2, what is its inverse? So that's what I'm going to be asking you for these next couple of questions. What do you see? So you're going to tell me what operation do you see? Do you see multiplication? Do you see division? Do you see addition? Do you see subtraction? What operation do you see? And then what would be the inverse of that operation? Okay, so let's start with number 1. What do we see? What operation do we see exists here? Multiplication. We see multiplication. So I'm going to write that down. I see multiplication. So then what is the inverse? Division. So what we're going to do is we are going to divide. We are going to divide. Now, think of things being balanced, keeping things fair. We want to make sure that it's fair, right? If you go home and you're with your sibling and you're like, hey, I'm hungry, my sibling's hungry, but my parents only gave my sibling a snack, is that fair? No, not fair at all, okay? So if your sibling gets a snack because they're hungry, you want a snack because you're hungry. You want to keep things fair. You want to keep it balanced. It's the same thing. Equations want things to be kept fair. So if I'm going to divide on one side, I got to divide on the other. I got to keep it balanced. They like it to happen on both sides. So instead of multiplying with that 5, I'm going to divide with the 5. Now remember, a fraction bar is division. So if I do 5 divided by 5, guys, what's 5 divided by 5? 1. Do I have to write the 1? No, remember, because we talked about it, right? That's that invisible math, that invisible 1. We don't have to write it. I can go ahead and just cross it off, make it look like it's a giant 1, and I'm going to put the X right down here. Then I'm going to do 5 divided into 30. So what's 30 divided by 5? 6. There's my answer. X is equal to 6. Okay, let's do problem number 2. Marshall, make sure you're copying the notes, please. Let's do problem number 2. First question I always ask myself is, what do I see? What do I see? What operation do I see here, Angel? I see subtraction. So let's go ahead and write that down. I see subtraction. Okay, second question. What is the inverse? So what is the inverse of subtraction, Guadalupe? Addition. So the inverse is addition. We're going to go ahead and use addition. So what am I going to add to both sides? If I want to get X all by itself, what am I going to add to both sides? Well, yeah, it's addition, I know, but what number am I adding to both sides? Well, what number was I subtracting? 8. So instead of subtracting 8, I'm going to add 8. We're going to add 8 to both sides. Now remember what I just did up above? I said, hey, if I subtract 8 and then I also add 8, it's as if it never happened. So what did I do? I boxed it off and crossed it out. Boxed it off, crossed it out, and then what's still remaining here is my variable. My variable is now all by itself, but I still need to do this portion here. I need to do negative 15 plus the 8. So I need to do negative 15 plus 8. What is negative 15 plus 8, Ion? Negative 7. Very good. And there's our answer. Okay, let's take a look at problem number 3. Let's identify, what do I see? So what operation is this when it's x over 4? What operation is that, Isaiah? Division. So I see division. I'm just going to use the sign. I see division. So what is the inverse of division, Brian? Multiplication. So the inverse is multiplication. So instead of dividing by 4, okay, and I'm even going to write that down. I said, I see that I'm dividing by 4. So instead of dividing by 4, I'm going to multiply by 4. It's really good to identify what number you're going to be using. So I'm going to multiply both sides by 4. I'm multiplying both sides here by 4. So if I multiply by 4 and divide by 4, I can cross those off, and I'm left with my x. But now I need to do 4 times a half. I need to do 1/2 times 4. If I do 1/2 times 4, what is that, Angel? 2. So we get x is equal to 2. And here's a really neat thing, guys. You can take your answer that you get, and remember when we did those evaluating problems where we took a value of x and we plugged it back into the problem and we worked it out? You could do the same thing here. I can do, hey, 2 over 4. If I do 2 over 4 and hit enter, it's going to equal 1 over 2. If I do 5 times 6, it's going to equal 30. If I do negative 7 minus 8, it's going to equal negative 15. So algebra allows a lot for self-checking. You can get an answer, you can plug it back in, and you can make sure it works. It's a wonderful, wonderful thing. Okay? All right, problem 4. M minus 8 is equal to negative 3. What do I see? Subtraction. I see that I'm going to subtract 8. I see I am subtracting 8. So what is the opposite of subtracting 8? Add 8, right? We're addition. So our inverse is to add 8. So instead of subtracting 8, we are going to add 8 to both sides of our equation. Again, I can box these 8s off and cross them out. That m is going to come straight down. And if we do negative 3 plus 8, negative 3 plus 8, what is that going to come out to? Positive 5. Good. Okay, so what I want you guys to do, turn it on over to the back. You've got a couple of problems on the back to try out. Try doing those on your own. Identify what you see, identify the inverse, and then work it out. Okay, let's go over these. We're going to identify again. Identify what the operation is, what is the inverse, and then let's work that out. So what do we see? For the very first problem, I see what operation? Addition. I see addition. What am I adding? 7.2. So I see that I'm adding 7.2. So my inverse, I'm now going to go ahead and do the inverse. What is the inverse of adding 7.2? Subtraction. So we're going to subtract 7.2. So we subtract 7.2 from both sides. Okay? By doing so, we now have x by itself because we can cross this off. It's all gone. We're going to get x is equal to 1.7. And there's our final answer. X is equal to 1.7. Okay, let's talk about problem number 6. What do we see? Nope. It's multiplication. When they're side by side like that, even though it's a fraction, the fraction is in front of the variable. That is multiplication. So I see multiplication with the 3/4. So what is the inverse of multiplication? Division. So the inverse, we are going to divide by 3/4. So instead of multiplying by 3/4, we are going to go ahead and divide by 3/4. So we take 3/4 and divide it by 3/4, those are going to cross off. We're then going to take 9 and we're going to divide it by 3/4. What do we get when we do 9 divided by 3/4? 12. Very good. So we get x is equal to 12. Okay, let's take a look at problem number 7. Problem number 7, what operation do you see? What operation is this? Nope. Division. That's a fraction bar where r is on top. Notice the difference. The reason this one was multiplication is because the variable's not on top. The variable is side by side. That's why it's multiplication. But in problem 7, the variable is a part of the fraction. The variable is inside of the fraction. So when the variable's on the top, when it's the numerator, that makes it a division problem. So I see that I am dividing. I see division by a negative 2. I see division by a negative 2. So what's the inverse of division? Multiplication. So my inverse is to multiply by negative 2. We're going to multiply both sides by negative 2. So if I do negative 11 times negative 2, what does that make r equal? 22. R is going to be equal to 22, a positive 22. Okay, for problem number 8, what do we see? I see subtraction. And what am I subtracting? I'm subtracting a negative 3. I see subtraction of a negative 3. So what's the inverse of subtraction? Addition. So I'm going to do the inverse. I'm going to add a negative 3. Right? We're doing the inverse here. We're going to add a negative 3 to both sides. So when I add a negative 3 to the negative 3 here, or, subtract a negative 3 and add a negative 3, those cancel out. And then I'm going to add a negative 3 to that negative 8. What's negative 8 plus negative 3? Negative 11. Good. Okay, problem number 9. Again, remember when they're side by side like that, is the variable inside of the fraction? No, the variable is not inside of the fraction. Is it side by side with the fraction? Yes. When they're side by side, what operation is that? Multiplication. So we see multiplication. I see multiplication of that 4/9. So my inverse operation is to divide by the 4/9. So we're going to take 4/9, divide it by 4/9. And then we're going to take 20 and we're going to divide it by 4/9. So if we do 20 divided by 4/9, what will that give us? 45. Good. Do 20 divided by 4/9 and we're going to get 45. Okay. Problem 10. I see a fraction. Is the variable inside of the fraction? Yeah, it's a part of the fraction. It's the numerator of the fraction. So when it is inside of the fraction, what operation is that? Division. Okay, so I see division. This happens to be dividing by negative 4, so the inverse is going to be to multiply by negative 4. We're going to multiply both sides by that negative 4. So I'm going to multiply here by negative 4. Those are going to cancel out. And then I'm going to multiply this side by negative 4. What's negative 2.5 times negative 4 going to give us? 10. Positive 10. Good. Yeah. All right. So what we're going to do now is we're going to get into a Nearpod practicing these one-step equations.